Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest, minimum changes to make say k semi-palindromes. The problem states that you are given a string s and an integer k, and you have to partition the given string s into k substrings. And the target is to make the number of literal changes required to turn each substring into semi-palindrome as less as possible. So what is a semi-palindrome? A semi-palindrome is a palindrome where you will take an integer d such that length modulus d is equals to 0, and for every index which have the same modulus by d, they should form a palindrome. So let's take an example. Let's say ADB GAD. So if we take d as 3, notice that the length is 6, so 6 modulus 3 is equals to 0, so d equals to 3 is a valid d. Now if you take d as 3, you can see this and this has the same modulus with 3, so 0 modulus 3 is equals to 0, 4 and 3 modulus 3 is also equals to 0. So these two string or a string with a and g should be a palindrome, and similarly d and a should be a palindrome, and similarly b and d should be a palindrome. So whatever changes you need to make ag a palindrome, da a palindrome, and bd a palindrome is something you will be required to make the given string a semi-palindrome with d equals to 3, and you can try out every possible d, and among all of them you can just pick the one which is giving you the least value, and that will be the minimum number of literal changes required to make any given string a semi-palindrome. We'll look at it with more examples, but let's move forward to an to a sample. ABC and k is 2. So basically we have to divide this string into two substrings, and if you can see here we have divided the string into AB and CAC. CAC is already a semi-palindrome. AB, to make AB a semi-palindrome, we just make B as A, and the entire both of the substrings or partitions are now a semi-palindrome with just one change. And you can try out any other partition, you will not be able to partition the string into two substrings such that both are semi-palindrome without any changes. So hence the answer here is 1. So before jumping into original problem itself, let's try to solve one smaller version of the problem where we just need to find out the minimum number of changes required to make any given string a semi-palindrome. Unless we solve this problem, we'll not be able to solve the original problem, which actually requires partitioning the string into k substrings. So let's tackle that first. We are given a string, we have to we have to figure out what is the minimum changes required to make this string a semi-palindrome. So as per the problem statement, we can choose any d, and all the indexes that have same modulus with d, they should be forming a palindrome. So what are the possible values of d for a particular string? So in this case the string length is 8, right? And the value of d should be a factor of 8, right? So the possible values of d are 1, 2, 4. Notice that 8 is also a factor, but we have been given that d can't be equals to length. So these are the possible factors of d. Now one of the we can choose any one of these, and based on what we choose we can figure out what is the minimum changes required to make the given string a semi-palindrome. So let's say we choose d equals to 2. So if we choose d equals to 2, we will partition the string in this format. Basically all of these crosses should be a part of same string, or should be a part of same string which we need to make a palindrome. For example, in this case, this is index 0, this is index 2, index 4, and index 6. So if you see, 0 modulus 2 or 0 modulus d is 0, 2 modulus 2 is 0, 4 modulus 2 is 0, and 6 modulus 2 is 0. So all of these indexes gives the same modulus with d. So these four characters should form a palindrome. So we have A, D, B, A. This should be a palindrome. And similarly, if you take these characters 1, 3, 5, and 7, these four also gives the exact same remainder. So 1 modulus 2 is 1, 3 modulus 2 is 1, 5 modulus 2 is 1, and 7 modulus 2 is 1. So these four characters should also form a palindrome. So if we are able to find out what is the minimum changes required to make this a palindrome, minimum changes required to make this a palindrome, then we can say the given string is a semi-palindrome with these many number of changes, right? In the same fashion, if d is 4, the configuration would look something like this. Basically, if d is 4, this 0 and this 1 would give the same remainder. This 0 and this 4 will give the same remainder, 0 modulus 4 0, 4 modulus 4 0. So AB should form a palindrome. Similarly, 1 modulus 4 is 1 and 5 modulus 4 is 1. So again, CC should form a palindrome. And in the same fashion, this D and this A should also form a palindrome. And finally, the last one, which is stars, this A and D should also form a palindrome. So if we figure out the minimum changes required to make this a palindrome, to make this one as palindrome, to make this one as palindrome, and to make this one as palindrome, and we'll sum them all up, and the total sum will give us what is the minimum changes required to make this given string a semi-palindrome with d equals to 4. And in the same fashion, you can figure out the minimum changes required to make the given string a semi-palindrome with d equals to 1. In this case, basically, we have to make this entire string a palindrome. So everyone will give the same remainders. If you see, 0 modulus 1 is 0, 1 modulus 1 is 0, 2 modulus 1 is 0, and so on and so forth. Basically, each of the indexes will give the same remainder. So all of them should be a part of single string, and that string should be a palindrome. So let's say this gives us x1. So sum of the number of changes required to make this one a palindrome plus the number of changes required to make this one as palindrome is equals to x1. Similarly, this gives x2. Sum of changes required to make this plus this plus this plus this a palindrome is x2, and this one is x3. So we can simply take minimum of x1, x2, and x3, and that will give us finally the minimum number of changes required to make the given string a palindrome, right? So now how to find these values of x's? So these are nothing but we have to find out what is the minimum number of changes required to make any given string a palindrome. So how to solve that? Very simple. We know that if this is a palindrome, the characters at the first and the corresponding character from the last should be same. So this A and A should be same, this D and B should be same. So if they are different, we need to change something for sure. So either we can change this D to B, or we can change this B to D. It doesn't matter, but we have to change one thing for sure. So we can simply pair up the elements and figure out which of these pairs are not equal, and for each of this non-equal pair you need one changes for sure. So in that way you can figure out the minimum changes required to make these individual strings a palindrome and sum them all up to actually get the value of all the xi's, and finally you will take minimum across all of them, and that will give you the minimum number of changes required to make the given string a palindrome. right? We haven't done anything fancy, we just simulated whatever is given in the definition of semi-palindrome here, right? So how would the pseudocode look like? The pseudocode would simply looks something like this. Let's just get rid of this a bit. So what we will do, as we discussed, we will go over all the factors of n, right? N is the length of the string. Now for each of the factor we will try to figure out, so for each of the factor, which is for each of the d, we will try to figure out these strings and also figure out what is the minimum changes required to convert each of these strings a palindrome, right? So the best way to get this string is basically just divide it into the groups of d, and just take the first one should be mapped with the first one in the second group. Similarly, second one should map with the second one in the second group, and so on and so forth. So that's what we have done. We simply divide it into groups, and each group is of length n by f, right? And we now will figure out what is the minimum changes required for this particular d, right? So basically we are trying to find out the value of xi here. Now for value of xi, as we discussed, we have to make some strings, and how many strings we will get, how many these kind of strings we will get, this is equals to d, because the modulus would be same only after d elements, right? So this will be equals to, the modulus would be repeating after d. So let's say some x is there, right? You will get this same modulus x only after d, without, or only after a multiple of d. Without a multiple of d, this remainder would never be x, right? So that's why we will simply go over, or like we will have only this d number of parts or d number of strings in total. Now for each of these d strings we need to figure out how many minimum changes required to make them a palindrome. So that's what we are doing. We will simply iterate over. So let's say this is the string, right? So this has like let's say this has 5 letters. So how we will figure out the changes required? We'll just pair up the first and the last, the second and the second last, and so on and so forth, right? So the same we have done. We simply figured out the leftmost pair and the rightmost value, and then we will figure out L2 and R2, and then L3 and R3, and so on and so forth. Basically we'll just figure out these indexes, see if they are equal. If they are not equal, I just increment the changes, and finally if this entire thing is done, we will get the changes for a single string. Now if this, once this entire loop is done, we will have the changes for all the strings, and once we have the changes for all the string, we'll simply do a minimum of whatever the value we have seen so far and the current number of changes. So this is the value of xi, right? So we just do answer equals to min of answer comma xi, and once we do this over all the factors, we will get our result, right? Now what is the time complexity of this entire solution? The time complexity depends on these three loops. First loop, we are iterating over all the factors. Second, for each factor we are iterating over the number of parts that we will have, so basically the factor's length itself, and then we are iterating over the length of the string that factors will form, right? So let's first focus on these two loops, right? So what what will be the number of times the first loop will execute? It will be executing f time for a given factor f, right? And what will be the number of times the inner loop will execute? So what is length? Length is simply n by f, so the inner loop will execute n by 2f times, right? So in other words, this loop in combined will be visited n by 2 times, right? Now these two loops is going or is getting visited for all the factors. Now how many factors are there for a particular number? It is root n in worst case, right? So these many number of this is the overall time complexity of this entire algorithm, right? Now we know how to figure out what is the minimum number of changes required to make a given string a semi-palindrome. So let's just call this as a black box, because we now know we can figure out the number of changes required to make a given string semi-palindrome in n root n time approximately, right? So now let's move forward to the original problem. And if you remember, the original problem was we have to divide the given string into k substring such that each of these k substrings are semi-palindrome, and we have to do this division in such a way that total number of changes required across all these k substrings should be as less as possible, right? So in this case k is 3, so we need to divide this given string into 3 substrings, right? So let's start with the first substring. So first substring would be starting from this particular index and can either end here, or it can end here, or it can end here, or after this as well. So basically let's say it ends at some index r, right? What is this r? We don't know, but we don't care as well. We know, just know that it ends at some index r. Now what you know, what you want to do, you need to just find out what is the minimum changes required to make string after r, or to partition the strings after r into k minus 1 partition, such that each partition is a semi-palindrome and the number of changes is obviously minimum, right? So isn't this problem exactly similar to the original problem that we are trying to solve? Original problem was we have to partition this string into k partition such that the changes required should be as less as possible. The reduced problem is we have to partition this reduced string into k minus 1 partition such that the changes required to make each of these k minus 1 partition a semi-palindrome is as less as possible. So hope you can see the recursion here. Now what would be the state in the recursion? Firstly, obviously index, because this will denote after which index I need to partition, right? And second is number of partition itself, right? So from a single, let's say you are starting from 0, right? So when you are starting from a given I, you will simply so when you are starting from a given I, you will simply try out all possible r's. So this is one possible r. Basically you are saying that the first string is only this much, and in that case you will say the minimum, give me the minimum number of changes required to partition the string after this r into k minus 1 partitions, and you will simply add the number of changes required to make this string a semi-palindrome, and that we already know how to calculate in n root n time, right? We have discussed that previously. So let's look at the formal recursion here, and then we'll look at the pseudocode. So this is how it will proceed. So we will, let's say we are trying to find out f03. Basically we have to start from the 0th index and we have to partition everything after 0 into 3 substrings. Now what are the possible choices? Possible choices would be we will simply take the first index in the partition, right? So we'll simply take the first index in the partition. In that case we need to now partition this remaining string into k minus 1 partition, or in other words 2 partition, right? So minimum number of changes required to partition the string after index 1 into 2 partition. And in the similar fashion, you can say, okay, the first string is ending here. So this is the first partition. Now we need to find out the minimum changes required to partition the string after 2 into 2 partition, and in the same fashion into 3, into 4, and 5 and 6, and so on, right? Now for this one, let's say you get some x1 value, right? You know the value of this one as x1, you get the value of this one as x2, you get the value as x3, and so on and so forth. Now you know that this is string A, and you know that this is the first partition is string AC, and in this case the first partition is string ACD, and similarly in this case the first partition is ACDA. So you will simply apply your previous changes algorithm and figure out what is the number of changes required to make this given partition a semi-palindrome, and let's say this comes as y1. Similar fashion, you will apply the changes algorithm here, and let's say you get y2. You apply the changes algorithm and figure out what is the number of changes required to make this ACD a semi-palindrome, and you get y3, and so on and so forth. Now you will simply do x1 plus y1, x2 plus y2, x3 plus y3, and take minimum across all of them. So x1, minimum of x1 plus y1, comma x2 plus y2, comma x3 plus y3, and so on and so forth. And finally you will get what is the value of, or what is the best value of f of 0, 3, right? So hope this entire solution makes sense. Now let's look at the pseudocode quickly. The pseudocode would be exactly similar. We will simply start from so this is the base case. We'll come to that. So we'll, for a particular index, what we will do, we'll just fix the end of the current partition. So end can be anywhere between the current index and anything up to n-1. Now once we have figured out the current partition, which is starting from index and ending at this nxt, we will simply figure out what is the number of changes required to make this given string a semi-palindrome, and what is the number of changes required to partition the remaining string into k-1 semi-palindromes, and we'll simply add them and take minimum across all such first partition that we can make starting from the given index ind, and finally whatever we'll get is simply our answer. Now it may happen that you might have to calculate the same state again and again, so to avoid that, this is simple memorization you will do. If you can simply iterate over everything and initialize them with -1. If it is not -1, it means that you have already computed that, and you'll simply return that value from here because you have already stored it after the computation, right? So what is the overall time complexity of this entire algorithm? So time complexity would be the number of states, right, multiplied by what's happening inside each state. Now let's figure out the number of states first. So number of states would be number of distinct value of index, which is n, and number of distinct value of k, which in this case is n by 2. So it's again kind of n. So number of states is n into n by 2, right? And what we are doing inside each of these state, we are first iterating over all the possible next indexes. So in worst case it can be n different next indexes. For each of the next index, we are actually calculating the changes required as well. So remember, the changes required was n root n by 2, right? We have seen this a while ago, and then we are doing some mathematical calculation which is just order 1, so let's ignore that. So this is the overall time complexity of the current algorithm, which is n power 4 into root n divided by 4, which will surely not pass because n power 4 is way huge for n equals to 200. So we have to optimize this. Now which part you can optimize? I would strongly encourage you to pause and try to think this piece by yourself. So hope you thought about it. The simple optimization you can do here is you can calculate this entire thing beforehand. What you can do is for each L comma R, you can compute what is the total changes required, or what minimum changes required to make the given string a semi-palindrome beforehand, and this entire thing will go away and will just be order 1 inside this function, right? So this entire thing would become n cube by 2, which is okay. So this entire function will be n cube by 2, which will pass the given time complexity, no issues with that. But you are also computing this thing, the changes required for every pair, right, or for every substring of the given string. So what you will incur extra, you will run this entire algorithm for every substring in the given string. So there are total n square substring, right? For each n square substring, you will be doing this algorithm, which is n root n by 2. So this is overall n cube root n by 2, which is also in the given time which will also pass in the given time constraint. Again, there's a small like issue here, not issue, basically the time constraint is strictly on the higher side, so you have to make sure that you are not iterating over anything twice in this particular piece, otherwise you will get TLE. As always, Leetcode is famous for unnecessary high time complexity. So the overall time complexity is order n cube for this piece, which is finding out this like doing this recursive algorithm to partition this into k substring, and then figuring out these changes as well beforehand, because we will be using this inside the string, inside this function directly, without actually without actually calling this function. We'll just store everything in a 2D array and just use that 2D array here. So that 2D array computation will take n cube root n by 2 times, and this entire thing will take order n cube time, which if you sum, it will be within the given time constraint. So if you have watched this point, I would strongly encourage you to pause and try to code this entire thing by yourself and get it submitted as well, because that's the most important piece when you are trying to solve. So let's look at the code. The code is very straightforward. As we discussed, we will first, so this is like finding out the factorial, the factors of a given string, which I am ignoring. I assume this you already know this. And then as we discussed, we first call this function for all the pairs or all the substrings in the given string, right? So for all jk, we'll call this function and compute the values. So this will the order n cube root n by 2 type, order n cube root n by 2 piece. So what this function is doing, exactly similar. First figure out the length, then iterate over all the factors. For each factor we have some parts. For each part we will iterate over the given string or half of the given string and see if the start and similar corresponding character from the end are equal or not. If they are not, I will increment the change. Finally, we will just do answer equals to min of answer comma change, and we will keep on doing this for all the factors. Whichever gives us the minimum, that is the minimum number of changes required to make the given substring L comma R a palindrome, right? Now, or semi-palindrome. Once we know this, we'll simply call min change of 0 comma k, which will give us the minimum changes required to partition the string starting from index 0 into k partition, such that each of them is a semi-palindrome. So this part is very straightforward. This is the memorization piece. Otherwise, we will iterate over all the next indexes. For each of the next indexes, we'll know what is the first palindrome starting for, or the first substring starting from index, which is starting from index and ending at nxt. And for this substring, we already know the changes required. So this array will contain the actual changes required to make this a semi-palindrome. And finally, we just call next plus 1 comma k minus 1, which is make everything starting from next plus 1 and divide it into k minus 1 partitions, such that each of them is a semi-palindrome. And the base case is if we reach the last index, or if we have exhausted every index, then we can't have any more partitions. So if k is 0, everything is good, we'll say return 0. Otherwise we'll return a very long infinity value, which in this case I have chosen 10 to the power 9, which should be sufficient as per the given time constraint, as per the given values, right? So hope this entire solution makes sense. If you have any doubts, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already, and I will see you in the next one. Thank you.